Okay, good morning. Good morning, one and all present here. Am I audible?
Yes, sir.
Yes,
You're
sir.
audible, sir. Audible, sir.
Okay. Good morning. At the outset, I welcome the proud alumni of our Global Academy of Technology, Mr. Amog G, who will be delivering his talk on relevance of artificial intelligence and machine learning in the mechanical industry. Mr. Amog G is a 2016 batch mechanical engineering alumni of Global Academy of Technology. He was a very active member in most of the Society of Automobile Engineering activities in the campus. In fact, he used to participate in a lot of events under the aegis of SA India during his stay in the campus. He was placed in entity data, I believe I am right, in 2016, and he completed his MTech from BITS Pilani in data science. He was a topper in heat transfer in his engineering program. After completing MTech from BITS Pilani in data science, he has also completed a management course from Symbiosis Pune, and he's been working in Mercedes-Benz R&D India as a data scientist. He has a what do you call a flair towards the data science, and he is a core mechanical engineer. Probably he can enlighten all of you today on the applications of AI, which is a most sort of kind of program in the present engineering this one curriculum and machine learning. I welcome Mr. Amog to today's alumni talk. Welcome, Amog.
Thank you so much, sir, for the
Okay.
introduction.
I also welcome my colleague, Professor Parmesh Rajan, for this event. He is also a co-convener for all the alumni activities in Global Academy of Technology under the aegis of IQAC cell. Welcome, Parmesh.
Yeah, thank you, Guru. Thank you.
Okay. I also welcome all the IQAC members and all my colleagues to this alumni talk by Mr. Amog. Amog, you can start your session. You can enlighten all the participants here. Thank you.
Sure. Okay. Yeah.
Please.
Yeah. Let me know if you're able to see my screen.
Yeah, Mark. Can I just make it as a slideshow?
Yeah, I have done it. Yeah. Can you see it as a full screen now? Hello.
No, for me it's not. It's not appearing as a full screen. It's still rotating. Let's hear from Guru.
Okay.
Guru, can you see it, Guru? Yeah, fine. Somebody said yes, sir.
Yes, but still it has to come little big.
Oh, I have shared it as a full screen now. Please let me know if it is visible. Is it visible?
Visible, but you need to make it full screen. Amog.
Okay. 1 second. I'll just
There is
connect
a
back.
side, yeah, you have to close that side document recovery.
Okay. 1 second. Yeah. One second. I'll just join back to the same meeting.
Yeah. I request the students to interact with Amok actively. Please listen to his talk and interact, ask any questions you have at the end of the session.
Yeah, hello once again. So can you hear me now?
Audible, audible.
Yes, okay. I'll share my whole screen now. Okay, can you see the full screen now?
Yeah.
Yes, yes, yes.
Okay. Thank you, sir. Thank you, Guru Nagendra sir, for short introduction. So today's session, and thank you for inviting. And first of all, a happy new year to everyone. So happy new year and prosperous year to you and your family. So in the first week of Jan, let's start off with something new and a trending topic which is going on in the industry. And I'll just let you know about the relevance of AI and ML in mechanical industry. So I'll just try to give a glimpses of the whole so that you'll know how the industry is going towards it and how it is for you as a final year student. So okay, today we'll just go through a basic introduction about myself and basics of AI ML. So and application and trends of AI. And after that, this is generally with respect to the market and the whole of the industry and AI, which as a whole in automotive industry. So I'll just also cover about the automotive industry and what work I have been doing for the last few years. And also I'll try to guide you on the
Leila.
trends and the topics to learn and how to come into this AI and machine learning field. Okay, so this is the basic introduction about myself. So as Guru Nagendra sir already mentioned, I was a 2016 pass out from Global Academy of Technology. After that, I did a PGDBA from Symbiosis Pune, and I recently am on the verge of completing my MTech in data science. So in 2016, I was placed from Global Academy of Technology to Entity Data. So it was a complete IT company. So there was nothing in mechanical in it. So I learned a lot of programming and stuff, Python related stuff, and I slowly moved towards automotive and mechanical domain in the same company. So in that way, it gave me an opportunity to learn about Python, machine learning, and a lot of data science stuffs, and I could work on a lot of POCs or the new topics uh, that that is being generally done in the IT industry. So after that, I worked in Tandem Loop Technologies for around 6 months. So there also we were working on building analytics tool and various other end-to-end products completely in web development and other things. And currently, my latest work experience is with Mercedes-Benz Research and Development India as a data scientist. So here, it all aligned properly to me. So the experience that I gained in entity data as a Python data science and everything came along with my experience in Global Academy of Technology for working with a lot of other stuff in mechanical helped me a lot to get into this kind of a role where mechanical domain was really important, and along with that flavor of Python and data science is the thing that I'm currently responsible for, and I'm doing it day in and day out currently. So that is in short about myself. Okay, you're able to hear me, right?
Yes, yes.
Okay, yeah, sure. Okay, then I'll just go to the next slide. You can stop me whenever you want, and you can ask me questions anytime you feel if you're not getting it right. So you're able to see the whole screen, right? Hello.
Participants?
Yeah, yes, yes, I can see.
Okay. Okay. So I'll just start off with the basics of AI, as we mentioned in the agenda. So yeah. So in AI, people think a lot of things like robots and machines are doing the whole stuff by itself, and there are a lot of misconceptions like that in the market. But I'll just let you know the basics of what is actually happening. Yeah, so artificial intelligence is like a whole umbrella, and machine learning and deep learning comes under artificial intelligence. So artificial intelligence is nothing but uh, hello. I can hear some disturbance.
I request all the students to mute their audio, please.
Okay, sure.
Yeah, continue, Amu.
Yeah, sure. Okay. So
Yeah, this
as I was mentioning, the artificial intelligence is nothing but it is actually training a machine to behave like how a human takes a decision at a point of time. So it is nothing but it mimics the
Amok,
human thought. Yeah.
Amok,
Sorry. Yeah.
I welcome Professor D.B. Ravikumar to the session also. Welcome, Ravikumar.
Hello, sir.
yeah, thank you. Thank you, Guru Nagendra. How are you, Amog?
Yeah, I'm good, sir. I'm doing good.
Yes, fine. Continue.
Sure. Okay, so as I was mentioning, artificial intelligence is like a whole umbrella where we train machines to behave or make decisions as a human does. So that is in just what artificial intelligence is. And as we see in movies and a lot of other things where human takes over the world and all that, it is all a broader misconception, and everything we are involved in a lot of stuffs where it is helping us in a lot of day-to-day activities in most of the industries, and many industries are going to go into this field, artificial intelligence and machine learning, be it civil engineering, mechanical engineering, medical, any construction, anywhere we find engineering work, it is going to go into a small piece of work will go into AI and machine learning in the future. So that was the understanding of AI. So what is machine learning then? So machine learning is nothing but it is just another branch or a subcategory of artificial intelligence where we deal with a lot of data which comes into the system. So be it any kind of data, maybe historical data, there'll be a lot of data points that are being collected in day-to-day activities. So a conventional CNC machine that you see, or a lathe, before we didn't have any of the electronic stuff before 20 years, but now in CNC there are so many chips, so many sensors that are being recorded live, and all this data are being collected for analysis, and it is being put to use for some or the other applications. So that is one of the small things, or it is applicable not only for mechanical, it is applicable for most of the industries currently. So machine learning is nothing but it is a branch of AI where we deal with a lot of data coming into the system, and we deal with algorithms, and we use mathematical simulations and algorithms to arrive at a results or a meaningful analysis. So that was about machine learning. And deep learning, which is even more a sub branch of mechanical machine learning, where where the uh, where the use cases are solved with a lot of layers in between. So in machine learning, we just use straight algorithms and mathematical functions. Here in deep learning, we actually build many different layers, and these layers are stacked together to filter the data and also arrive at a meaningful results from the data that we already have. So that was about an overview of what is the difference between AI, machine learning, deep learning. There are a lot of these are all the buzzwords which is going on in the current industry. I think you should clearly know because wherever you will go in the future, in whichever industry you go in future, there will be something or other related to machine learning or AI that you will be put to work in the future. Okay. So this is the classification of AI. So it is broadly classified into machine learning and deep learning. So as we saw in the previous slide, so in a broader area, machine learning is where we have data, and deep learning is where uh, we don't explicitly train it, but we actually uh, simulate it with neural brain neural networks, something like that, something of a brain structure. We program it in that way. So machine learning is broadly classified into supervised and unsupervised learning. So But in an overview, I'll also share a few examples going forward. So supervised learning is nothing but we actually train a algorithm uh, to perform and to train using the historical data. So if we have historical data and we want to predict the future, we use supervised learning. Whereas in unsupervised learning is where we explicitly do not have any historical data, but we actually need a result immediately without training a model or without having anything in the past. So that is where unsupervised learning comes into picture. And coming to the deep learning side of it, so we have another two major categories where computer vision is one of the major things, uh, and NLP and NLU. NLP is nothing but natural language processing, where we play a lot with text and everything is with human language and human language, text, and other things. So where we have a lot of other analysis going on there. So from Google searches that you do, everything is with deep learning, NLP, and the basic search that you do on Google actually comes with NLP. And yeah, I'll just any doubts till now for anyone?
No, nothing. Go ahead.
Sure. Okay. Yeah, fine. Okay, I'll just give you a glimpse of how it is classified. So, in deep learning, there is called something called computer vision. You would have definitely seen computer vision in some or the other way. In basic, in your own phone, there might be Google Lens. So, if you scan anything on Google Lens, it will tell you what is the object, or it will scan a barcode. Everything is comes under object detection, computer vision. So another major application of computer vision is being used in mechanical drawings and automatic QA/QC tools in mechanical drawings. And another one major which is going as a buzz in the worldwide is automated driving cars. So automated cars also has this computer vision where it has cameras and it will detect anything on the road, obstruction on the road, and it will automatically take care of the route and aligning of the route. And the second part is natural language processing, where uh, everything is with respect to the language that we speak or we write. So NLP helps in understanding the human language as a colloquial as we speak and write. So basic example of NLP is nothing but chatbot that we use daily. You would have definitely used a chatbot in various applications, or um, you have in many things that you have come across in day-to-day life itself. Okay, so okay, coming to machine learning, supervised learning. So this picture gives a gist about what is about supervised learning. So we'll have a raw input data. It is all about historical data that we have, and we feed it to the algorithm, which is the second part, and we do the model training. So that model is actually trained and it is processed. And once the model is trained, if we give a sample which is very close to the input data as an input, it will say that it is the input. For example, we have apple and bananas, which we are feeding into the algorithm. And after we get the model, we give an input as an apple. So the model will perform and it will tell me that it is an apple. So it might seem a very basic example, and why is it applicable and where is it applicable? Well, it is applicable in various fields. So be it finance and even the predictions, or even the COVID case prediction that you see in day-to-day activities. So even in COVID cases, there are a lot of data points which is feed into the algorithm. So all these data points are actually modeled, trained, and they give an input for the date and other. This is just a simple input I'm giving as an apple, but even for the model, it'll the basic data point would be date. So that is how they are predicting the COVID cases even in the future. So they tell that the peak will going is going to be hit by February or March. That is how they have a model in place which is trained for a lot of data from the past and the various behavior of humans, and that is how the training is being done. So that is about supervised learning in machine learning. Okay. Uh, so this is the another one, another category of machine learning called unsupervised learning. So here in previous example, we saw that there we had data. We knew what green color is an apple, yellow color is a banana, and we knew the data point that it is this way. But in unsupervised learning, sometimes we don't know that what is the data exactly. Is red the apple? Is banana yellow? So we don't know that. So we do not have a historical data explicitly, and on the fly we need to categorize the data into different categories and arrive at a conclusion which is helpful. So as you can see, we have a raw input data. We don't know the output. So and there is a training and interpretation being done, and algorithm trains with the data that we have fed, which doesn't have any label points or anything. And after processing, all the apples, the two apples are categorized into one place. Bananas are categorized into one place. Mangoes are categorized into one place. So this is a very basic example that anyone could understand. That is why I thought I'll just show you in this manner. The same functions, like for example, even in automated driving cars, while analyzing what is on the road, the obstruction, the signboards, everything has to be categorized and only then analyzed. Otherwise, it will be very difficult for the algorithm to understand and even navigate the automated cars. So this is a basic example or the underlying algorithm which takes place uh, in automated driving car as one of the application or example. So similarly, we can even have a fraudulent transaction in credit card. So or your debit card, the usage that you use, sometimes if there is a fraud transaction, that can easily be categorized if there is an anomaly. So in any anomaly detection, unsupervised learning is the one which is being majorly looked at. Okay, so this was the basics of AI and what was the broad category and how it is classified. So so now let me go into the application. So we've dealt with a lot of different things and overview of AI and its subcategories. So where is it exactly used? I was mentioning that AI will take over a lot of domain and lot of industry. So some point of the other, all the conventional engineering topics has to be converged, maybe in future down the lane, and everyone has to be working with AI and machine learning, because we are moving into such market and such category of world where the data is huge and everything works with AI and machine learning. So there are various applications which can be found using AI. So the first thing, let me take as manufacturing. So even in manufacturing, there is AI is being implemented in a huge way, where the production capacity is being increased using AI and machine learning, and another the downtime has been drastically reduced, and time to the market has been reduced a lot. So that is where it has been majorly implemented. And the next one is IoT. So IoT is where the whole Internet of Things, where every machine has got is being continuously monitored, and all the data is sent over the cloud and being stored in the cloud system. So all those data are analyzed and can be controlled anywhere over the world, over the internet. So it is controlling the machine over the internet, and sometimes not just controlling, even the smart decision wherever necessary is being taken using IoT devices. So a small example is, even if you have seen any smart home or a smart bulb, automatically it switches off if nobody is around, and based on your movement it will judge you. Yes, there is a lot of sensors which is being there, but there is a fair bit of AI and ML in IoT devices which is being continuously coming into the market. And automotive is a major area where AI is being implemented. So nowadays there is no a plain conventional car. So there has been at least uh, every detail of a car is being monitored using an ECU, and all this data are being recorded and been stored somewhere so that it can be analyzed and been, for example, the engine data, exhaust data, your acceleration, braking system, everything is being recorded some or the other place, and those data is being sent to the cloud and being analyzed over and over continuously again in automotive. So the same thing even in automated cars. So AI is the one of the major things that you can see as in self-driving cars, where all the data are being monitored continuously. So another application is supply chain and packaging. In any industry, you need to have warehouse, you need to have raw materials, and all this. There has been a major impact if there is some mismatch or downtime in this supply chain. So AI and ML is directly being utilized, and there are a lot of results being directly observed in supply chain and packaging, where the raw materials are ordered correctly. The storehouse management and everything is being monitored using machine learning. So design is another field where the CAD CAM that you generally see, and I think you would have already been come across in your engineering courses, where the designing in various softwares. So there is called something called generative design, which is being taken into major shape, where you just have to uh, give an input of how the product should look, and it'll optimize itself, and it'll automatically create the product, uh, taking the cost into the matter, taking the raw materials which will go into the product, and also the size and other another lot of things which goes into the matter. So you just have to give those as input, and it'll automatically uh, take everything into the algorithm, and it'll design its own products. So this is something called generative design, which is hugely getting invested in mechanical industries for AI, which is also called AI in design, mechanical design. So another application is predictive maintenance in machines. In a lot of mechanical industries, they face a lot of losses because of the machine downtimes and everything. Nowadays, all this the machine's data points are continuously getting captured, analyzed, and being reported into the a machine learning algorithm, where it will tell us that this a particular machine is going to go into a downtime in the next few weeks. So get it rectified, or have a maintenance before it goes into the downtime. So in that way, you can come in beforehand using the data, and you can analyze a lot of stuffs, and it is also giving a lot of profits and another various enhancements and innovations are being done using AI and machine learning. So these are not the only applications that I'm showing you. I'm just showing you a gist of how it is happening. So apart from this, also there are a lot of applications which are being done, and there are a lot of things in the market where AI and machine learning are being the future of any industry. Yeah, so I have a small video to show you the applications of AI. I don't know whether you'll get the audio. Let me know if you're able to hear the audio. Are you able to listen to the audio?
No.
No, is it? Are you able to listen to the
No.
audio?
No.
Oh,
No. We are not able to listen to the audio there.
No,
oh,
you need to
okay.
share it. You need to share the when you're playing also, you need to share along with audio.
Okay, I'll just do it again. Yeah, let me know if you can hear it now. Is it audible?
Yeah.
Okay. It's a small video. Just
When everything becomes linked with everything else, matter becomes mind, and the possibilities become endless. Imagine 50 billion IoT connected devices by 2020. Now, imagine the economic impact of these connected machines. $4 to $11 trillion per year by 2025. Wearable devices, environmental sensors, agricultural machinery, components in a vehicle, or devices in homes can all be connected to deliver insights and drive transformation. So imagine if you had smart devices in your home, your car, your workplace, or even on yourself. The world becomes alive. That's Internet of Things. The Internet of Things is making everyday objects into data factories. When Internet of Things, along with big data, meets artificial intelligence, this interface will become enlivened with intelligence, and a new world will take birth, which will increasingly talk back to us. Imagine the kind of world that it would be. Imagine the revolution it will usher in the way we see the world. The external world will become the extension of our mind, like an extension of our thoughts. Imagine a world that is responsive, a world that is optimized for human creativity, a world that is intelligent. The Internet of Things is a breeding ground for new AI-driven solutions and experiences, from self-driving cars to intelligent homes to health. Welcome to the world of endless possibilities. Welcome to AI and...
Yeah, so that was the gist about applications and trends in AI. So it gave us a lot of insights about what can AI and machine learning do. So that was about a brief about how it is going to be in the future. And I trust me, I am actually seeing a lot of things in present in my workplace and how it is going to be in the future. So in the next 15 years, I would say that there won't be any conventional manufacturing of any conventional cars. It will completely be electric cars and completely be automated cars. Maybe 50% or 70% of the cars would be automated cars, where a lot of machine learning and AI stuff would come into each and every aspects of a automobile. So similarly, you would have seen it has got applications in maybe smart homes, healthcare industries, agriculture, and a lot of other stuffs which we can even cover. So you can even imagine everything will come under AI and machine learning. So possibilities are endless here. So you can hear me, right?
Yeah, we can
Hello.
hear you.
Yes. Okay.
Yeah,
Okay.
we can hear you.
Okay. So I'll just come to the next set of the topic. So AI in automotive industry. So this is where I'm currently working, and I am actually getting this data in ground. So as you can see in the left hand side, these are the literature, technical literature which are being published almost till date, and it has been uh, even in the naive stage, and it is still early days, I would say, in automotive industries and most of the industries where AI is being implemented. So everything is being in the POCs and research state. In the next 5 to 10 years, I think that will be the major trend, and the whole job market and even the technical things would drastically shift into these topics. So as you can see in the left hand side of the graph, so for engine optimization and battery optimization is where the most of the technical literatures are being published. So there will be also been publishings on emissions and transmission components and everything. So it is still in the starting phase, as you can see. So and there has been even the product till the production stage. There are few topics which has already gone into production, and we are able to see it in the working and in real world scenarios. So the right hand side shows you about different automotive industries where AI is being integrated. So for performance optimization, So you can see hybrid vehicles, internal combustion engines is where major things are being happening. So I would frankly say that IC engines would stay for another 15 years, and most of the automotive giants are moving into electric cars, and there won't be production of IC engines at all. It will just be optimization, and there won't be any new design probably in the next 15 years. So everything would be electric and automotive, or autonomous driving. So there has been a small amount of portion even in heavy earth moving vehicles. So electric vehicles is still in the early stages, and you can see even in aircraft industries there has been a lot of AI related work being going on. So this tells us about the how AI in automotive industry is placed currently. So, so there are some of the use cases which are being done continuously in cars. So as you can see, the first thing is engine optimization, where a lot of data points are being collected and being analyzed continuously. There are a lot of researches being going on in motors, batteries, and you can see in exhaust systems. So the first one, in the left side box, you can see there is the first thing is basically on engine optimization. So how efficient an engine is for various conditions, everything is being analyzed, and there are a lot of R&D work being done here. So the second one, since we have battery optimization, and even the whole engine is being replaced by the battery. So when this happens, there are even more lot of data points which is being gathered, and it is being continuously taken care and monitored and fed into AI systems to optimize a lot of features of the car and the efficiency and the output of it. So there are even emission controls. So currently there are, as you can see, there are a lot of topics or research being done here. So in diesel engines, in petrol engines, in diesel engine especially, there are a lot of NOx emission and a lot of other harmful gases which is being emission, and it has to be controlled continuously. So all this has to be monitored, and there has to be a clear feedback mechanism which is being set up in place. So this AI helps in all this, and a lot of predictive analytics and even anomaly detection in exhaust systems. Everything is being monitored here continuously. So there are even a lot of miscellaneous other things like inside the the OS inside car. Everything is being monitored continuously, and even you would have already seen in Indian market a lot of cars with AI driven dashboard, so which will talk back and it will make uh, things work for you. So that is still the early stages, and still a lot to be seen in automotive. So another thing is majorly the calibrations. Engineers play a major role here before a new car comes into the market. So even in calibrations and a lot of report and analytics, AI is being continuously used, and it is being helped with to the automotive industry. Okay, so this is another detailed topic of engine performance, since we saw that engine is a place where AI is being maximum being utilized and implemented. You can see there are four major topics in engine, where air fuel parameters, engine parameters, torque and related parameters, and vehicle parameters. So these are the four broad categories of engine, where it is being taken as input parameters, and it is being fed into the AI systems and being optimized every day. So there, you can see there are a lot of companies like General Electric, Toyota, Caterpillar are pioneering research in this domain. So even Daimler, Honeywell, a lot of automotive giants, Volvo, everyone are being continuously using AI for engine optimization and performance. So yeah, here you can see Hyundai, Doosan, and even heavy earth moving industries are continuously trying to implement AI. So the major reason for this is the whole conventional systems are being replaced by ECUs and electronics. So by using these kind of systems, we get a lot of data, and with the data, we get an ample opportunity to work with data and also optimize the design and help in efficiency. So it works like a feedback mechanism where we can actually improve our next models, or even the research are being actually coming into the real world manufacturing systems. Okay, so I have another video for you. So which will just tell us about, which will just summarize about AI in automotive. I'll just play this. Let me know if you are able to listen to the audio again. You're able to listen, right?
Yes, yes. Go ahead.
Okay.
Yes, we can listen.
Okay.
Pop culture has shaped and formed the public perception of a technology that theoretically exists since the mid-50s, artificial intelligence. In short, AI. However, the term AI is often misunderstood and used incorrectly. AI is not some personified voice over the air that answers arbitrary questions, some omniscient intelligence that knows everything. So, what is AI then? The answer is quite simple. AI provides methods and tools, like a Swiss Army knife, to assist and automate tasks for which typically human intelligence is required. Artificial intelligence made its breakthrough with performance and statistical learning on large data sets. Deep learning is pushing the technology further and further to learn complex patterns and provide predictions. AI technologies thus enable applications for future cars and car development processes. Automated driving can use AI methods to detect objects in the environments, such as vehicles, streets, and road signs, in order to plan a maneuver. For several years now, Mercedes-Benz cars already use similar technology to detect and classify pedestrians as such. Inside the car, systems like the Mercedes-Benz User Experience, MBUX, provide recommendations and predict user preferences. But not only customers benefit from enhanced in-car functionalities, development and manufacturing of vehicles are also supported by AI-powered tools. When engineers analyze test data from cars during the development phase, AI methods identify anomalies and assist them in finding issues at an early stage. Machine learning algorithms are able to find patterns in vector fields of air circulation in combustion engines. In doing so, machine learning helps to increase the maturity ramp-up during development. Reducing development time is also achieved by self-calibrating systems, for example, for a modern transmission. Deep reinforcement learning can be applied to infer feasible calibrations in a software-in-the-loop environment in early development stages. At Mercedes, colleagues from AI research, IT, business units, and external partners collaborate together to explore and implement the possibilities of AI applications for the future.
Yes, so that was just about what is going on in AI or machine learning in automotive industries. So one of the part, very small part that we are going, I am into one of the teams that takes care of a small part in automotive. So that was about AI in automotive. So any questions till here?
Amog, can you hear me?
Yes, yes, sir.
In the slide you have mentioned, what is that feed forward and backward propagation one of the slides.
It is one of the techniques, AI deep neural network techniques that is being used.
Where do
It is
you
one
use
of the
backpropagation? Where do you use feed forward neural network? Exactly.
It depends on the various data that we collect. So based on the complexity of the data, there are a lot of algorithms that we develop. So it comes under the deep neural network. So where we actually develop a neural network based program and feed our data into it. So feed forward propagation is also based on the data complexity. So based on that, we identify where the data should go into which algorithm based on the efficiency output that we get, and in that way we use it.
So which one you use for supervised data? Feed forward or back? Is it?
Both are actually supervised learning, because all these are we actually use all historical data from the cars, and everything is being fed into the system.
Okay, thank you, thank you.
Okay, so since everyone is from the final year, I just thought I'll make a few slides of what are the career opportunities and how to land into this kind of work. And uh, I just thought I'll just give you a gist about it. So there are majorly four job roles: data scientist, data engineer, ML engineer, and data analyst. So data scientist is the one who actually tells the company to what should we do with the data and how do we do it. So he is the one who knows everything about the data, and he'll tell us what to do with the data if we have the data. So that is the one that data scientist does. Data engineer is the one who actually prepares the data from the raw source to make it available to make run some tests on it. So he is the one who constructs the whole architecture of data pipeline and everything from the source to target. So ML engineer is machine learning engineer, nothing, but he'll just work on modeling the AI algorithms, and working with the data and getting the results with probability and statistics. So he should know probability, statistics, mathematics, and lot of algorithms. What happens actually behind the algorithm. So I have been telling a lot of things as algorithm and mathematics, statistics. So I would say just a simple mathematics that you would have learned in your 12th standard. Y is equal to mx plus c, which is a straight line equation. Even that is a machine learning algorithm for linear regression. So the whole data is fit into the line, and y is equal to mx plus c is a line that passes through major points. So that we used to do it manually, if you remember, in our school days. So the same concept is being extrapolated, and it is being helped, and it is being used for predicting the future. And the last one is the data analyst. So he's the one who works with a lot of data and gets reports and a lot of fancy graphs. He is responsible of building all those and giving it to the companies to make better decisions at the right time. So these are the major four broad categories that you can land up in if you are into data science and data engineering. So, and last thing is most of them, a lot of people reach me like, how do I land up into this job role? Since this is the one of the hot job role, and everyone wants to shift into this role. So how do you land up into this? I just thought I'll just put a four broad line. This is not just it. You can even go into deep and venture yourself. But I would say for going to data science and scientist, you need to know basics of programming. Oops. And trust me, even I am mechanical engineering, and I didn't know anything in programming or anything of that sort. So I learned it, and it is very easy. Within a matter of few weeks, I think you would learn basics of programming. And once you are good at mathematics and basics of statistics and programming, you can directly go into Python and data science. So Python is really easy. I recommend everyone to learn Python. So whichever industry you land up in, you will definitely work with Python in either in some or the other way. You would, if you know Python, it'll be a great impact for your future as well. So it is very easy to learn. There are a lot of online platforms like HackerRank, Solo Learn, and even a lot of other things. Even I did not take any I did not take any course or anything. You can learn everything online by yourself without anyone's guidance. So it is really easy. So especially I can promise you that most of the colleagues who I worked with in AI and machine learning, at least 50% are from mechanical engineering. So it is very easy and we can learn it very quickly. That is what I would say. And yeah, after you are good with programming and Python, you can start with basics of data science, algorithms and stuff, and start implementing it in real life scenarios. You can do small pilot programs or small pilot projects, which are also available in online. So there is a site called kaggle.com, which is you can learn from basic to even advanced competitions are going there, where you can refer it and you can easily uh, learn data science and Python in those platforms. So finally, after you learn everything, you have to keep updating yourself in this field. So you have to constantly learn and deal with data and lot of other things, and especially uh, to be called as a data scientist, or you have to know domain knowledge. So that is your mechanical stuff. So whichever industry you're working in, you should thoroughly know it first. Only then you can be called as a data scientist. Otherwise, even only for example, even CS people can do this easily, but they'll never be able to relate to what we actually go through in mechanical stuff. So most of the industries which are taking uh, this into shape is like they need to have a strong domain knowledge. So be it civil engineering, be it mechanical engineering, healthcare domain, manufacturing, you need to know strongly. So that is why you have an upper hand, I would consider, than most of the CS guys, because they will never have the domain knowledge as we do. So the mechanical engineering stuff that you have learned in your engineering will come a long way to you. So along with your mechanical engineering, if you have Python and data science, then it is nothing like it, and it is like really good, and you will be at your top of your industry for the next 10 to 15 years. uh, any questions on this?
Yes, Amok,
Yeah.
Kiran here.
Yes.
Hello,
Yeah, tell me, sir.
can you hear me?
Welcome, Kiran. Please go ahead.
Yeah, Amok, you told about many applications where we use this AI and ML over there. So
Yes.
probably in the case of an engine management system, or also say in order to enhance the productivity, or also say even in the case of supply chain management and all, you said about the various applications. So probably can you just let me know as how we can apply this AI in that because these are all the different things where we do apply. Can you
Yes.
just let me know as to how exactly we can apply it?
There are various things like, for example, in supply chain, in which domain do you want? There are a lot of applications where we can really think of it, and everything is data driven. So if we have data, we can actually work with it, and we can find meaningful results and help in uh, arriving at a meaningful results. And there are a lot of insights that can be got through the data that we already have. So for example, in healthcare industry, so we have a lot of data of patients and lot of other data points of how they are being monitored with various data points, and all these are coming into the algorithm, which are fed into the algorithm, and we are able to predictively analyze the history of the disease, and we can tell them that maybe in future you might get this disease. So in that way it can be implemented.
And also, you said that there are two kinds of algorithms where we need to train, and the one which is not like a supervisory algorithm and other things where we need to
Yes.
train the algorithm. Other one we did not train. So
Yes.
probably I didn't get an idea. Like when you say training training a model, what does
Yeah.
it mean exactly?
Okay. for a simple example that I told you, y is equal to mx plus c. So we plot all the data points x and y in a graph. So and we actually draw a line in between. So that is actually training. It is nothing but training. So all the data points that you already have, you have to feed into a algorithm, and it will learn by itself. So learning is nothing but the best fit line. So the intercept and slope concept that we have seen in y is equal to mx plus c. So the slope keeps changing. So based on the maximum number of points that it covers through the line, so that is the best fit, and that is called learning in algorithm terms. So that is a basic example. So there is a sinusoidal, not just straight line. There are parabolic curve, a type of line, and lot of other series lines. So based on that, we fit our data. So we put all the data into the graph, we fit the line, and that line is being used for prediction. So that is called training and prediction. So that is supervised learning.
Okay. You mean to say that like whatever the optimization techniques that we are going to use it, so probably that can be implemented to the models through which we can train it, right?
Yes, correct. So training is nothing but you need to have historical data, and you need to know the point. For example, I would say a simple thing is rainfall. So you know what is the rainfall for the last 100 years in the month of December. So you can train the whole year data into the model, and you can exactly predict what will be the rainfall for the next month. So that is the optimization that you can arrive at by training the model. So in that way, it will help our, and all these are still in the basic stage. So efficiency, if you see how efficient is it, how accurate is the results that we get through the algorithm, I would say it is still in the market. Everyone has got their own algorithms, and it is somewhere varying between 70 to 90%. So even 70 to 75% is good enough in most of the cases. That is what the industry believes, and it is still going to improve based on the techniques that we use for the data. So based on the data that we get in every scenario, the algorithm changes, the technique changes, and in that way the efficiency or the output accuracy also changes.
And thank you, Amu. Thank you, Amu. It's been nice listening to you. Okay, fine.
Yeah.
Thank you.
Okay. Anything else? I've just got a few time slot for open discussion. Maybe if anyone, students or anyone, if you have any doubt, maybe you can ask me. My sincere suggestion for everyone would be just to get involved in a lot of other things apart from academic.
Amog,
Yeah.
there is a question by one student, Sujit.
Okay.
In chat box, he has written this. I want to know why Mercedes does not produce cost-efficient vehicles, which could be even bought by middle-class family. If it's about comfortability, I feel even Alto is comfortable for me.
Very good question. So they are actually they are not coming into the economic section as well. They are only their main focus is only luxury brand, and they stay. It is only for the brand, and most of the parts that they use is the high end stuff, and they are not coming into the this bracket or this Indian economic segment itself. So they are only targeting their target is only the upper middle class, and most of the things is that is why it is costly.
Any
And
questions?
even if you take any German brands, most of the German brands are in the higher side. So be it the cost and maintenance, everything is higher in German brands. Majorly because of the brand image and the quality that goes into it.
Any doubts? Any queries, participants?
Sir,
Yeah.
I just want to ask, can you brief us on the experience on Mercedes R&D department? Like, what is Mercedes R&D currently working on?
It's a huge organization, so there are a lot of things going on. So we cannot explicitly tell it outside, but anyways, I would maybe briefly tell there are AI and machine learning and data analytics team which works day in and day out on exhaust systems, on powertrain, engine. Whatever video that you saw, we actually do that stuff in reality. So there is a lot of team and everyone does a small part. It is impossible to do everything. So everybody is responsible for small stuffs. So maybe you can take autonomous driving cars or even customer cars. How is it performing? Will engine go into any anomalies in future? Predicting that and letting the customer know in beforehand. All that is being done in our Mercedes R&D. So that is one of the another reason why the cost is also higher because even though the customer is still there, the R&D still goes on and even the feedback is still there with the sold cars.
Okay, thank you.
I would maybe a small advice that I would seriously suggest everyone to maybe go through basics of Python. It'll hardly you will I promise you'll easily learn it within a month or so. So it is easily understandable and learnable even in online platforms. And also apart from your academics, please try to do something else apart from academics, which is being valued a lot when you go into the interviews or even in the job. So the projects that we have done in our in my college when I was in Global Academy of Technology, it is valued even in even today in Mercedes as well. So that is how it is impactful. If you do something, even if it is small, apart from your academics, it will help a lot in your career. So I have another small video compilation of what we went through when we were in college in 2015 and 16 on Formula SAE on building the cars. So in a brief, it is just around 1 or 1.5 minutes. So I would just like to uh, play it through for you. Yes, that just gave a glimpse of what we went through, the work that we did for the 2 years when we were in engineering for third and fourth year. So it was great working. So thank you, Guru Nagendra sir and Global Academy of Technology for inviting me to give me a lecture on this. So it was an honor to be here.
Thanks, Amog. It was a nice talk.
Thank you, sir. Thank you. I was really looking forward for in-person meeting, but because of the situations, it couldn't happen. So, anyways,
Definitely, you can come anytime. Okay. Right now we are facing third wave COVID.
yeah,
After few days, we'll invite you for open talk offline. Okay.
sure, sir.
That's a good message for our students. Okay.
Yeah.
Thanks for everything.
Thank you so much, sir.
Yeah. Guru Nagendra can take care. Hello, Guru Nagendra. Guru Nagendra sir. Am I audible?
Yeah,
Yeah.
Amog,
Yes,
am I
sir.
audible?
Yes, you are audible now.
There is one question. What is the application of AI in aeronautical industry?
Okay, I have not explicitly worked on aeronautical industry, but
That's one
there are a lot
student
of
Okay.
yeah. So from manufacturing, as you see, everything comes under manufacturing. So and there have been a lot of software systems which is being put into aeronautical industry. So there has been a lot of use cases which is still being developed in aeronautical industries as well.
Okay.
So
Thank you,
from
Amog. Yeah.
from engine systems, so even that has got engines. It has got pilot, autopilot mode, and everything. So everything is being considered, and even AI use cases are being implemented there as well.
Okay. Thank you, Amog, for taking your time and enlightening the students on the relevance of AI and ML for the mechanical engineering industries. At the outset, I like to thank the management and principal of Global Academy of Technology for supporting the alumni initiatives. I also like to thank all the IQSC cell members, in particular Professor Parmesh of Computer Science Engineering Department, who is the support behind this activity. I also like to thank all my colleagues, faculty members, Professor Ravi and Professor Kiran, who was part of these proceedings. I like to thank all the participants who patiently listened to your talk, and I hope they have benefited a lot. Okay. Thank you, Amok. Thank you all for being present here. We like to have much more events or talks like this from all the alumni, and we want all the alumni to chip in and help the alma mater in enlightening the students, offering some internships and things like that, which really go a long way in helping the department. Thank you, one and all, for your patient listening. We'll meet you next time. Thank you.
Yeah. Thank you, Amog, for your
Thank you, sir.
association once again. Okay. We'll continue this association. Okay. Let us have an offline sessions here afterwards once this everything comes to
Sure,
normal
sir.
condition. Okay.
Yeah. Really looking forward.
Personally, we'll meet. Okay. Thanks
Sure.
a lot. Thanks a lot, Amog. Okay.
Thank
Thank you, Guru
Thank you
Nagendra
all.
sir and Parmesh.
Thank you,
Kiran.
Ravi. Thank you.
Thank you. Thank you.